Hello. Uh, I'm Gabriel. I'm from Data Scientist, and I wish to welcome you to our highly well waited for webinar with Tristan Post. Tristan Post is a senior AI strategist. He came to the idea to be an AI strategist and to be more with AI after taking a course in the university in machine learning. After that, he decided, well, I leave the academy and start to concentrate myself on, well, on the how it goes in the society. So I would like to ask you to ask your questions in the chat. And Tristan, the stage is yours.
Well, thank you so much, Gabriel. Hello, everyone. I'm very excited to be here today. I mean, this is my second talk now. Actually, this is my third talk. Last year I gave a talk, and this year I gave another talk about the value of AI. And today I would like to talk a little bit more about the machine learning lifecycle management from a much more holistic point of view, and thinking about, well, what you actually have to do to really create value with your AI project. So let's look a little bit kind of like very shortly about me. My name is Tristan Post. I'm based in Germany, Munich. I'm an AI strategist. I'm faculty member for Gen AI and AI at BCG, mainly working as a freelancer at the moment. I'm a lecturer for artificial intelligence at the Technical University of Munich, as well as the Munich Business School. I used to build up one of the largest startup incubators for AI in Europe, AI Founders. So if you want to found something, this is a cool place to go, also located in Germany. And I used to be an ex-senior AI strategist for Applied AI. So very excited to share a little bit of my work and what I'm doing and how I think about kind of like this management of this whole machine learning lifecycle. So how can we think about it? What is the goal really here? And what we see when we kind of like look into the economy is that actually most of the AI projects fail. What do I mean with fail? They never really make it kind of like from going to a proof of concept to really going to the final stage where it becomes a product that sits in our operations and it is used by people. So hopefully by looking a little bit at the various points of the machine learning lifecycle management, we can better understand what actually needs to be done to make those AI projects successful. So what we have to do is to understand how can we go from a simple AI output where we have an input coming in, we have AI doing the processing and the output, to really go from data, AI, and then generating value. And for this, I brought kind of like a video to showcase you one of this or one kind of like end-to-end machine learning project, what I find quite funny. Unfortunately, we had some troubles or problems with the sound. So hopefully it works. I'm going to show it to you, and I don't think the sound will work, but I will talk a little bit over it to give you an understanding what it is about. So what you can see here is basically Benham, who talks about his cat metric. However, he has kind of like he's facing a couple of problems because the cat is coming in quite often with prey into his house. And what he tries to do is actually find a way how he can solve this by using artificial intelligence. So here he talks about how kind of like he came to the realization that he doesn't kind of like want his cat to come in. So he thinks about what can he do as kind of like in a low code or no code version to really start building a project where we can have a smart cat clap that he can basically train. So he sets up a camera, takes pictures of his cat coming up the ramp, and he's training several kind of like models and labeling a lot of data. Several models is he labeling and training, ones where the cat is actually coming in, ones kind of like where the cat might have prey or might not have prey. And then basically he uses kind of like this training with this camera, kind of like building a model. And this model he uses, and you can see how he's basically labeling thousands of data points that he's generating with his own camera to build what is a smart cat clap. So basically every time this cat is coming and is having prey, the clap is supposed to lock, So here, basically, the first stage, the model asks if the cat is coming in or if it's not coming in. And if the cat is basically coming in with prey, it should lock the door clap and send money automatically to the Autobahn society. So here he kind of like talks about how the model has been running for a couple of weeks and worked actually quite well. And he has been, not really kind of like having a lot of complaints. And I think only once or twice the smart clap unfairly locked out the cat. So sorry that this is a bit of clunky. I hope the sound was working, but it's not working. So what does this mean? Kind of like if we look kind of like at the normal process of a machine learning lifecycle, what we have, we can see kind of like what we have the data, how do we generate data, then the AI part, how we can use the data to kind of like train our models, and then the operationalization part, really bringing this AI into a working product. And this time, in this case, it's our cat clap. And then we can only generate value if the product is really working in the workflows. So the idea of machine learning lifecycle management is combining artificial intelligence and put it into an operational model. And this is traditionally called machine learning operations. So this is basically uniting a little bit of engineering, data platform engineering, infrastructure, machine learning, and software. And this is what we traditionally call machine learning ops. But what I realized kind of like when working in the field is there's a crucial aspect missing, because we need to understand not only how to build these AI products and systems, but also how can we integrate them into existing products so that people also know how to work. So in this what we call is a more human and process-centric MLOps approach. And I give you an overview, and we will dive deep into all of these individual points in a second. So when we look at this, what we have is kind of like what we see, what we go is kind of like involves a lot of different stakeholders, a lot of different players that have to play together to really make kind of like this whole project a success. So what I want to do is go in these kind of like different steps from scoping, data, modeling, deployment, usage, and monitoring, maintenance into much more detail and explain you a little bit the theory around it so that you really have kind of like a good understanding what it really takes to deliver a full-fledged project. So let's start kind of like with the scoping, and what you have to understand. This overall is a very iterative process where you might have to go back and forth and so on. So what is the idea of the scoping? So the scoping is really to understand kind of like coming from a problem and trying to find a solution to really build a use case that works. And if you remember from last time, what is a use case? A use case is a clearly defined set of activities designed to reach a specific goal from a business or customer perspective, in which one or more AI solutions are involved in reaching a respective goal. And what we have to ask ourselves all the time, well, do we really need artificial intelligence to do? So here you see, for example, so the video I've taken it from YouTube, and you see one person asked, well, I like this approach, how you solved it, but couldn't it have been just easier to place a scale there and kind of like measure the difference in weight of the cat to lock it? So you have to think about, is AI always the best way to solve the thing? And quite often, I mean, it doesn't have to be AI or kind of like really cutting edge tool. So I always say, well, what it depends on is like, we shouldn't focus so much if it's AI or not, but we should more focus on the value that we can provide. And in the end of the day, it doesn't matter if it's fairy dust, AI, or magic. So what we want to do, kind of like go from an AI idea really to an AI use case to really understand how this whole project is looking like. And what I always say, well, if you have the end in mind, the better you understand how this idea, how this product that you're building is going to be used with the end user, the easier it will become to build something like this. And I want to go through these stages, giving a concrete example. And again, for this, I have a video, but for this video, it's a little bit easier to explain what to do. So I want to give you one clear use case we are going to work through. So for this use case, we see actually that the French authorities have been using AI during Corona to detect unauthorized swimming pools. So what they basically did, they used satellite image data to be able to detect swimming pools if there's kind of like a swimming pool in the backyard. And then what they're doing, and what you're going to see in a second, is that they have been checking those swimming pools against kind of like the land registry to see if the swimming pool has been declared or has not been declared. Because the idea is, if kind of like they have been building the swimming pool and not declaring it, they have increased the value of the property of their or kind of like of their property, and are actually paying not enough taxes. And what they're using is basically they have rolled out this, and they were able to collect almost 10 million in tax revenue, just kind of like rolling out this one single use case. And I want to kind of like use this use case to really show you kind of like how you can think about it and more or less how it has been done. So what is the goal here? What's the scope, or what is the problem? The problem is here we have a lot of undetected swimming pools. It would be impossible for a person to check this or do this. So maybe we can use AI to really help the French tax authorities to efficiently detect these undeclared swimming pools to ensure a proper taxation. So what do we have to do and how do we start? Obviously, now we have the scoping. We understand what we want to do. We understand what is the goal in mind. Now we have to start with the data. So this was the part, if you remember, we have to, sometimes you have to set something up to be able to collect the data. So why do we need data? The idea is kind of like what we're doing is we want to build or train an algorithm. And for this, we need data. We need training data to train our model. And then also we need to test the model on this data set that we have. And then we have new data that is kind of like data we generate from the field, and then our trained model gives a prediction if we're going to see a swimming pool or not. So when we're talking about data, we have to firstly kind of like identify representative sources. So what are kind of like, how is the data going to look like in production? And what do I have to set up to collect kind of like this data that is more or less best, it would be the same data as I will have once this product is in production. So what I want to do is kind of like, I want to generate representative data that is as representative of what I encounter in the real world, in the real process as possible. So in our case, what we have is kind of like, this is a computer vision problem because we want to use kind of like image data. And just kind of like to give you the anecdote of computer vision. So what we need is kind of like a sensing device. We need to have our images, likewise very much how we humans sense. So we have our eyes as sensing device. And so what we need to put up is also, we have to think about what is the sensing device. I mean, in the example of the cat, it was kind of like setting up a camera that can help us to generate the data that we can use to label it. In the example, obviously, of the French tax authorities, the camera will be a little bit more higher up the ground, and it will be satellite data. But we're going to see this in a second. So once we have set up kind of like our sensing device or have gotten our data, we have to think about, well, what can we do to bring this data, to maybe clean this data and bring this data really in a form that we can use it to start training our models. And you see kind of like, it's actually not as an easy task. And to show you the example, what I mean with bringing the data in the right order and cleaning it is when we show kind of like, look at kind of like this data set or this table, and you see kind of like just kind of like people manually entering the data, how many mistakes or things that can happen, from contradictions to wrong representation to double entries, maybe even typos, some incorrect values. And we obviously have to account for all of these things. And depending on where I get the data, I will have more problems with this or not. So one of the biggest challenges anyhow is not only being able to get the data, but getting the data in the right quality and bring it into the right quality. And this is when we're talking also about strategy and how to set up with a company. The best thing is not to be at the stage in the middle of the product, but make sure that the company has the data in a quality that makes it very easy to build a lot of these use cases. So once we have done this, let's go to the next step and think about what we can do, right? So now that we have the data, we have to think about how can I use the data to build a training set and a test set. So what we have is we collected our data, and what we normally use is kind of like we want to split training and testing set. So we want to have one set where we can train it on, and the other set we have to use to test it on to see how good the models performed. So in our example, with kind of like the satellite images, so where would you get the data? I mean, we need satellite data, and obviously, or hopefully there are, or there are a lot of kind of like resources where we can get almost live satellite data that can be used to train. And depending on where you are, you might have already kind of like a labeled data set, or we need to label a data set. So we need to make use of this. Right. So here we can see, and we might have to even kind of like label and train the data set to be able to recognize those pools. And if you're talking of this, there are different ways how to do this, right? So we could, for instance, say what we want to do is we want to have bounding boxes that is just able to recognize the kind of like the swimming pools. But if the question we want to solve was not only being able to detect the swimming pool, but if kind of like the size of the swimming pool would also determine kind of like by how much the property price would be increasing. Because if I build a massive swimming pool, this obviously means kind of like the property becomes more valuable versus I have something very small. In this case, it's not so dependent, but I would go more for a segmentation to have a better estimate of the size of the swimming pool, right? But in this case, this doesn't actually matter because it doesn't really depend on the size of the swimming pool. So here it would be enough to have bounding boxes. But you see, really depending on the problem that you want to tackle, you have to treat the data a little bit differently. So it's always very important to understand where you want to go, and again, having this end in mind. So now we have kind of like all this data, and what we want to do is kind of like we want to have this the training data where we can train our models on, and then we want to have the testing data. So we pick, maybe in this case, we can pick data or kind of like pictures that might be a little bit more tricky, and we can see, okay, there might be some challenges in the model that we want to understand. How good is the model performing with outliers? So for instance, when we have a basketball court that is blue, obviously it's not a swimming pool. Or what happens with these swimming pools that have a unusual shape, or when we have the presence of a lake that is obviously not a swimming pool, or kind of like here we see we have also a bigger swimming pool but a different color, that it's green. So kind of like this is kind of like a good testing set, at least visually testing set, that we can understand, because we see, I mean, these parts seems to be a little bit more tricky. So, and again, understand that we want to have, when we kind of like use test data, it shouldn't be the same as the training data. And the question is why? I mean, it's very similar to how you would test kind of like people on a or quiz people on a test that they understood something. So let's say I'm a math teacher and I want to see kind of like if you have understood a certain topic, and we have 100 questions I can ask you with. In order for you to kind of like learn a certain topic, what I could do, I could give you all the 100 questions, and I can take 10 questions out of these 100 questions to give you kind of like a quiz and then see how good you do. The problem is, if I do this, I don't know how good you understood the things, because what you could have done is you could have just memorized all kind of like the exercises, and then you're just kind of like very good at memorizing and repeating the answers. So a better thing, what I should do is kind of like out of the 100 questions that I have, I just, for instance, give you 90 questions and I leave 10 away that you haven't seen. And those 10 I use to test you. And this is very similar to what we're trying to do with the training and the test data. And this is why the testing data should never be the same as the training data, because we don't want to test how good the model has been at memorizing the underlying things, but I want to have a model that really kind of like can predict well or generalize well the underlying ideas. So this comes to the next part, to the modeling part. So again, what I'm trying to do here, I'm trying to take an untrained model or algorithm, use the training data to train it, and then pick the best model that I have trained that can then perform. So the idea of model training is, if I have my data, what does the model do? It kind of like helps me to set kind of like decision boundaries. So if I have data and what I want to do here is separate the green Y's from the red N's, is then the model would be kind of like this line, and depending on what model I would pick, it would be different or could be looking different. And this is just kind of like an abstract example on a two-dimensional space. And then with training the model, I want to find kind of like the right angle that I have to use. And then I have a trained model that I can use to make then these predictions. So if a new kind of like observation would fall in the green area, it would be predicted as a green yes. And if it fall in the red area, it would be predicted as a red no. So then kind of like what does the model, an algorithm do? You can think about it very abstractly, just kind of like different ways how to put these lines. And what I want to do, what is a good model? A good model should be doing especially one thing. It should not be underfitting. So what does it mean with kind of like underfitting and having a good fitting model? So if a model underfits, so this would be, for instance, my model, and this is my training data. The model gives me the prediction. So if I have a new observation, the model would predict to be it somewhere on this line. And underfitting means that if I kind of like test it now for new data, I will see that the model lacks the depth and complexity that is needed. So I can see that here it would make quite a lot of mistakes. And I always say this is like very similar to saying, well, half knowledge is worse than actually ignorance. So it's really not performing very well or giving kind of like good things. On the other hand side, I can do overfitting. So this is basically, I train a model perfectly on my training data. So you see kind of like it fits it perfectly. But now when I put in the kind of like my new data, my test data, what happens, it fails to generalize the new scenario. And I see here, because it perfectly learned kind of like the distribution of my underlying model, what I have is I have quite some big mistakes that I can see here. So it also doesn't seem to make a good job at telling kind of like how, or being a good model and telling me what is really happening in the world. So what I'm trying to go for is to go for a model that has proper generalization. So it could be looking something like this. And you see, if I put in the new data, it seems to fit quite closely. So I want to have a good balance between the extremes of underfitting and overfitting, so to ensure that model is performing well under real world conditions. So just think about it. So I don't want to go for underfitting, overfitting, but I want to have proper generalization. So, and how do I do this? I mean, again, what we have is quite often that we see now, we have our our data set, and we want to, in order to ensure that we're picking the best model, what we have, we split the data that we have in a training set, a validation set, and actually a third set, a testing set. And then what we can basically do is we kind of like train our model on the training set, or train several models. Then we evaluate the different model performances on the validation set. And then we tweak and fine tune it to even make it better and better. And then we pick the model that is performing best on a validation set, and we test it one last time to confirm the results on the test set. And I mean, over time, there have become some different philosophies. I think when you started, there was kind of like no validation set. It was just training set and testing set. I've seen people kind of like using different style, obviously, to kind of like validated their models and the model performances. I've also people seen kind of like using several validation set. So it kind of like, it really kind of like depends a little bit on how you want to approach it and what you want to use and kind of like your underlying data. But the main idea of it, kind of like just thinking more from a conceptual perspective, is what we want to do. And if you're going to go back to our example, we want to kind of like train various models and then see which model is performing the best. So here, this is the example from kind of like the swimming pool detection. We have 3 different kind of like deep neural nets that we are kind of like, that we're training on the data, and we want to see which one is performing the best. And we take them from the retina net, and it's a 50-layer model, 101-layer model, and 152-layer model. And if this is not kind of like so familiar, don't be confused. But basically what we're trying to do is kind of like, we just think about, we're trying to kind of like try out, I don't know, kind of like 3 different cars that are the best for kind of like a specific task. And we see, okay, which of these cars is actually going to perform the best on certain benchmarks. And then this is the car we're going to pick for when we kind of like want to be in the real world. So just as simple as that. Just think about, we're having 3 different models, and we just want to see which one are the best ones. So what are ways to kind of like test really the performance of the models? And what we have for this is quite often what we use something as a confusion matrix. And I'm pretty sure it's called confusion matrix because it's so confusing, and I always have a hard time to kind of like not make mistakes when I go through it. So what we have is basically, if you think about it, if we have something with 2 choices, we want to understand what is the true class. So what is kind of like really what is happened, the underlying truth. We call this also the ground truth. And we want to see what the model is predicting. So think about again about a swimming pool. The true class would be positive. So we have a swimming pool in the picture, or it would be negative. There would be no swimming pool in the picture. And then what we have is the predicted class. So what does our model says? Positive, the model says it thinks there's a swimming pool in the picture. Negative, it doesn't think a swimming pool in the picture. And we always kind of like start kind of like from the prediction. So we see, well, it's positive and it's really positive, then it's true. And then we look here, is it positive? And here it's not really positive, so it's false. And the same as we have it here. So it's negative. We start with the prediction, but here it's positive, so it's a false negative. And here, if we go, well, it's a negative, and it's really a negative, so it's a true negative. So just think about maybe using an example to make things a little bit more clear. So we want to kind of like detect if there is really cat or not, and our model says cat or not cat. And we can see really this is the positive cat, the positive class, the ground truth. Is it a cat or is it not a cat? And here you can kind of like see to better understand it. If it's predicted positive, it says both times the cat, and obviously just here it's right and here it's wrong, and so on. And then we can use the statistics to actually make some inferences and say something about which model we want to predict. And there's some kind of like metrics we can use. One metric that is used, for instance, can be accurate, or is almost always used, is accuracy, to understand, well, all correct predictions over all predictions. So every time it got really everything right over all the predictions. Then what we have as well is a precision. We want to understand how often did it really predict the true outcome that we're looking for, the swimming pools, over how often it predicted that we have a swimming pool. So this would be looking like this. So often did it actually really say cat over every time it said cat? Also how often did it get the cat right? And then we have recall, but there are many more. So the last one that I'm mentioning now is just recall. So all the true positives over all the true positives and the false negatives. So we want to see cat. So we want to basically see, okay, well, how often was the class actually true over how often predicted it kind of like the true. And they're kind of like, this is not the only way how to measure things. If you're kind of like in the visual domain, the nice thing is we can kind of like see visually and try to understand visually how good the model is, not just by using data. But for instance, if we, for instance, have bounding boxes, or if we have segmentations, we can try to see, well, how good or how perfect is basically the overlay, and how good does it fit the ground truth, our predictions. So this could be something like this. And you see here, the model would be performing very good. And here the model wouldn't be performing so good. So let's look again in this our specific example at the testing set and test out the 3 models and see how good they would be performing, right? So what we have here, we see kind of like the RetinaNet 50. We see it makes quite a lot of mistakes when it comes to the basketball court. Here, it doesn't catch the green swimming pool. Here, it predicts a lot of swimming pools. Here, it thinks these kind of like solar panels are swimming pool. It doesn't seem to be so good. If we go for the RetinaNet 101, it seems to be much better. And I think that's the nice thing why I always like to show kind of like these visual things, because we have a visual understanding if they're actually performing good and well. And you see here, it's a little bit off. Here, it's a little bit off, but it does much, much better, but still not as good as our ResNet 152, right? And you see this one seems to be the best performing. And likewise, so now this is the visual representation. We can also kind of like look, well, for the true positives and the true negatives. And you see kind of like here, it has very kind of like the one that we picked before, the 152, has the most true positives. We can also see the true negatives. Here it seems to be performing also quite good, not as good as this one, but also when we're talking about false positives and false negatives, you see kind of like the level of false positives and false negatives is actually quite low. It has a very high accuracy. It has the highest accuracy of all the models. It has the highest precision of all the models. It has the highest sensitivity. And you see there are also kind of like other metrics I can test for. And this really depends on the case. And I'm not kind of like a big data engineer or kind of like data scientist. I just want to kind of like give you kind of like this conceptual insight. So even though, and you have seen when we're looking at this machine learning lifecycle management, a lot of the tasks are not on the technical side, but it can help to have at least an understanding that we have different matrices, and depending on the problem, I want to look out for different things. So here again, in our example, what we have is this one seems to be the best performing ones, and then we use it. And what I want to show kind of like what is very interesting if you think about how long does this process take? And most of the time, the longest time does actually the data training part take. And what I find quite interesting, if you think about in a company not setting out one use case, but a lot of these use cases, we're going to see how kind of like with the approach of new technology, it becomes easier and easier sometimes to train these models. Because a couple of years ago, you would have to label everything by hand. And now there are tools that make it, for instance, very, very easy to label those swimming pools. And it becomes easier and easier sometimes to actually work on this. So now that we have built our model that can detect if there is a swimming pool or not, we have to think about, well, about the deployment. So how do I put a model like this into my operations or into a product, into my operations and so on? Because I say, well, now you can detect swimming pools with AI. Tell me more, because so what and who cares? I mean, how do I generate value? Well, this is not really a product yet, and I have to really put it into a product, right? So what I'm always referring to and what this means is basically thinking about, well, we have now our new data coming in, it trains our model and gives a prediction, but how do I get value out of this prediction? And what I'm referring to is there's no value until we can trigger an action, until we have a product. So for instance, if you can think about here, so here we have a model that can predict whether a transaction is an outlier and might be possible fraud or not. Well, there's no value into it unless we put it here, for instance, into a product or a feature in this case, where my customers are getting an email or getting an SMS every time something like this happens, and they ask you, well, is this, there might be kind of like a fraud alert, and did you attempt to do the transaction? You can say yes or no, and then you can block it. And this is how you can get value. Or likewise, just think about your model that predicts whether the face or image is you. There's no value into it until we, for instance, put it in the iPhone to make it very easy to unlock. And then this could be a good feature where we can kind of like create more value for our customers, because now they don't have to put in the PIN code. And for this reason, they might prefer the iPhone over other devices. I mean, the iPhone was back then one of the first smartphone providers that had a system like this. And this might have been a benefit for them because more people went actually for the iPhone. So always think about, how does this tie kind of like the one single use case that I'm building to my overall value that I have? Or can it be, I'm building a model that can predict employer churn? What does it mean? It doesn't always have to be a product, but I have to use this information. So for instance, when I see an employee that might be likely to churn, it might make sense to talk to him or to give him incentives to stay. Or maybe it's an employee that I would anyhow like to let go, and then I shouldn't do anything because I know the employee is actually churning, but I shouldn't kind of like tell him you have to leave and so on. So really kind of like these models are only valuable if we really use them. So if we can put them into a workflow. And that's why I'm saying what we have to think about when we're building these models, we have to think much broader, because the AI model is just one small part of it. And we have to understand, how does it fit into my product or into my technical environment? And this can be hardware, it could be software, the network infrastructure that is really supporting this model or built around the model. And quite often you will see that the AI model might be the smallest part in each of these projects. And then obviously, I also need to figure around, well, what are the processes around it? So how do people use it? How they should engage with this product? And this is very important to understand, because this might change actually how I have to develop this product. And this is quite often overlooked. So what I'm saying is, well, going from this prediction of the swimming pool doesn't add a lot of value, and really having a product helps to add a value. But going from here, and this is my AI model, to building something that checks if the swimming pool is then registered against the land registry and understands, is this an illegal swimming pool? And then building a product out of it that is then used by people is a completely different task. And only then I can create value. And you can think about what I'm saying, why you should keep kind of like the processes in mind, because this is just like one simple example. I don't think, like, I don't know if they really kind of like put it like this, but let's say you have two choices. Do you want every time an illegal swimming pool is detected, should there be a governmental inspection and should there be a person going there and ringing at the door? Or does it mean we send them kind of like an automated email or mail, or we just kind of like directly, because we are the tax authorities, take the money from their bank account? And depending on what are the processes and what are the choices, I need to train those people completely different. And I also need to think about certain things, because one question could be in this example, well, am I actually would I be actually allowed to send people there to the houses? How would they react? Would they find this nice? Probably not. And what happens if I make a mistake? So these are kind of like all things that I have to keep in mind, and that's why I'm saying it's so important to have the end in mind. And how can I force you to really have this end in mind? Here, what I want to talk about usage. And I always say, okay, well, we have to think about two things. We have to think about the people involved, and we have to think about the processes involved. And we have to understand them, how kind of like the current state is. So how was it before the solution was there? That we need to understand what happens during it. So once we roll out, do we kind of like need to train those people, or do I need to change something just during the rollout? And also thinking about afterwards. So how is the world going to be once the solution is deployed? And especially I like to deep dive into kind of like the people part, because it's very important, very crucial to understand that we have different stakeholders in there, that I have to think differently about it. So we have to think about the decision makers. So who are the people that actually buy this product? Are these the managers? And it's also very important if I want to build my own startup, because to understand who is the buyer and who is the user, and because who is the one that's paying for it. And do I want to make the product that I'm building more valuable for the buyer? Because then he gets, maybe if we have kind of like this, I don't know, this churn prediction, maybe I add some features where the buyer gets specific insights the user doesn't have. Or do I want to build a product for my user, make it more attractive, because that makes it more attractive for the decision maker? So, and these could be different parties and they could have different interests. And I need to understand this. And also I need to develop an understanding for the people affected. So in this case, kind of like the people who are getting sent the letters or who have to pay the taxes. I have to understand, well, how will they react once this has happened? Will they be annoyed? Will they suddenly start to litigate? Because this could be happening, because people are not happy, maybe that they're kind of like someone looking up from a satellite into their garden and figuring out these things. So this is something I have to plan in advance, because I know if they will litigate, I might have to check with the legal department first if I can actually build this. This should not be happening once the thing is in process, because it could kill the whole project and cost me a lot of money. And that's why I'm saying we have to keep the end users very early in mind, and we have to understand who are the different stakeholders. And one important thing, if you're the person that is actually building this, right? So if you're actually building this and selling this as a startup, and kind of like want to sell it to a customer, and they might to have a solution on premise, I need to think about who are the implementers, maybe the IT, what are the requirements that they need to make it as easy as possible, because these are the ones that might have to implement it. Is it, do I have to come and install it? Because then it would mean maybe I have to an installment fee. Or is this something like a web application they can easily use and they just need an internet provider? These are all things I need to think about. And if you are in a startup, you need to really know all of these things. So once you have kind of like thought about this, let's think about how you can roll this out. So this is what I call deployment and training, because we want to train people how to use the product as well, if people are actually using the product. So I think about who could be a first good pilot, who could be kind of like a customer that is representative, and I test out the product with the pilot. So in the case that I'm making mistakes, those mistakes are not so costly, and I already can collect a lot of good feedback. This could be your beta users. This could be, I don't know, your parents or whatever. It really depends on what you're doing. Or this could be your ideal customer and so on. And once you have a pilot, try to decide, okay, does it make sense? Is it actually valuable to continue to roll it out? Do I have, and here we're talking about the KPIs and setting the right KPIs. And when I'm talking about KPIs for a successful project, I don't talk about the the performance of the model. No, the KPIs that really matter are people actually using this model. What is the cost of it? What is it making me money? Is it generating me profits? How many people are using it? And think about those metrics are completely different to machine learning metrics. And then think about, okay, well, once you have your KPIs and you should set them at the beginning, think about, do you meet the minimum requirements and can I then roll it out? And there are also a couple of strategies, kind of like how you can kind of like roll those things out and how you can release those things. And make sure throughout kind of like a rollout processes, there are kind of like different ways how you can kind of like roll things out, from pilot user to a limited rollout to a gradual rollout to a full rollout. How can you collect feedback and push the release further and further? And how can you use the rollout to collect very important feedback that can help you in your engineering, in your product, or in the design of the product? And if you look kind of like at the example in France, what they did here was very interesting. They kind of like just picked a couple of regions as pilots, and then they decided to roll it out all over France. And not only this, they also thought about, okay, well, how they can do different things. So you see here, so they tried it out. If it works, and what they want to see, they want to see if they can also detect other home improvements, like kind of like these other buildings that they have. So the first proof of concept for them also was the swimming pools, but they want to see if they can roll it out on much more things. So the next part would then be, once we have to roll it out, we have to monitor it. And this is also a requirement with the AI Act. And what we have to understand is, well, how can we kind of like monitor it and collect good feedback to improve it and also make sure it's running smoothly? And there are two important things how we can monitor it. So on the one hand side, on the data and for understanding how is the performance of the data and the prediction. And then we can also look at the system. So how are people interacting with it? How are the processes and how are the infrastructure? So let's talk a little bit about kind of like this monitoring part from a data perspective. Why do we need to do this? Because we want to avoid data drift. So data drift, there are kind of like different ways of data drift. So we have sudden drifts, for instance, in the distribution, but this will mean that my model is not performing as good as it used to be. And just think about data drift. Just think about the example of the cat. So it could be that my cat is becoming sick and is losing all its fur. And then I probably need to retrain kind of like my model so it kind of like detects the change in my cat. Or just think about I'm getting a second cat. Obviously, it has not been trained on the second cat, so I need to think about how can I retrain it. And obviously, so if you think about this is my decision boundary and what can happen with data drift, if I have data drift things like this, it wouldn't be as problematic as I have a data drift where it kind of like we have completely it changes or we have worse predictions. And this is super important. I want to show you kind of like the case study of Zillow. So here the danger of AI model drift. So from Zillow, this is basically what they do. They had kind of like the Zillow estimates where they have iBuying. So the idea is that you can put the details of your house on Zillow, or you could do this, and it would directly give you the quote for your house, and you could kind of like take the money for this. And how did Zillow kind of like wanted to make money for it? Well, they wanted to be able to do a couple of predictions. They wanted to predict, okay, how much is the real value of the house if you put it in? Then how much should I be able to kind of like to offer you for the price? So if your house would be the real value would be 1 million, then it would maybe go for 800,000. So basically, you make a profit with this because you give the people directly the money, and they might want to sell their houses fast. So you make 200 revenues. And then also there was like a third level, and things about, okay, well, if you can do a little bit of refurbishment, taking nicer pictures, maybe you can't sell it even for 1 million, but maybe for 1.1 million. And here, then you have made 300K in profit and revenue. What they failed to foresee was with Corona, what happened, that the whole housing market completely changed because people didn't want to live in cities anymore. They moved outside and so on. And they failed to adjust kind of like this estimating things. And because of this, they lost 500 million in revenue because they overpaid a lot of the things, and they had to lay off 25% of the staff. And this is something I don't want to happen to you. And this is why we need to monitor those things and also need to retrain those things. And this is the idea that over time, quite often, the models, the accuracy can decay. Just think about if you're using a camera over time, the camera obviously will get worse and worse and worse. So it's kind of like a natural decay in things, and you are most likely to see this in the model. And one way to do this is use kind of like new data I have to constantly retrain or update the model. And the other hand side, what we have is kind of like the system monitoring. Well, we need to understand the objectives of the system monitoring to ensure the reliability, to maintain security, and to really optimize performance. So what are areas to monitor is kind of like technical glitches, user behavior, how do they like that, what is the feedback, security, whether kind of like what is about data integrity and so on. So really kind of like understand what is important and why it's crucial and what you can do, kind of like taking regular audits, really kind of like tools for monitoring, applying certain monitoring perspectives, tools for having user activity logs, and so on. And just really think about it. So this is more or less kind of like the whole idea of a human and process-centric machine learning operations, really understanding kind of like why it's so important. And I hope I could give you a little bit the idea why it's really important to have kind of like the processes and the human in mind. And this gives us kind of like this bigger picture where you can see that AI is a very multidisciplinary topic where a lot of people have to come together and work together. And it's also a reason why I said in my professional life, I've never written a single line of code, but I'm most focused kind of like on these kind of like overall product or business management and thinking about how to generate value. And I'm never the one going to be kind of like, I'm not the most amazing coder, but I also don't have to do it. Right. And so think about how these different puzzle pieces fit together and what you have to do. So you try to scope, try to understand if there's a value, have the data part where you collect the data, and also kind of like do the data engineering. So putting the data in the right form, have the model from training to evaluation to picking the best model, and then really use this to develop a product and think about the deployment and the usage before, during, and after, and then have continuously monitoring and maintenance, so product management. And the idea, if we really focus on this human process-centric part, really think about what is going to be the production environment. So what are the technical specifications that the product needs to have? The people, who are the decision makers, the users, the affected people, what is happening before and after, and the processes, also how they're going to change before and after. How do I need to train the people? And only then I've been able to come from input to AI to prediction to generate real value. And then on top of this, and this is kind of like the next time I'm going to talk about it, is thinking about, well, how do ethics, how do governance and regulation, and how does security fit in all of this? And yes, this was my talk for today. I hope you find it insightful. I hope it helped you to get a better overview over this whole kind of like process and what is kind of like involved. And now we have time for questions. And maybe you can share. I'm always very happy to connect, and maybe you can put into the chat also as well my LinkedIn profile. Always very keen, very active in the field to connect with you guys when you liked it. Always happy if you leave a comment. It keeps me pushing to keep on and doing the things that I'm doing. So yeah, thank you very much, and I hope you enjoyed it. And I think we have now 10 minutes for Q&A.
Thank you very much, Tristan, for this highly insightful, webinar you gave us, and which is, as I have the position, I will not ask the first question, but summarize a very important thing, which I've seen. It is really seeable that you were studying philosophy next to your other topics, because you are really talking about the human-centered approach. You're talking about creating value, what we should do more. And this is this human-centered approach in human and process-centered approach is highly, I feel it's very effective, but in the same time, it is very making very much interest to our next webinar with you, Tristan, on the 17th of July on the topic Applied AI in Ethics. So now I would like to open the field for the questions. Let's start with the first questions of Lam. During the discovery phase of the product process, how do you find potential users willing to answer questions about the specific user case?
So this is an excellent question. I mean, I'm working a lot of with startups, especially if they have an initial idea and think about, well, how can I validate the idea? And what you have to do is kind of like to understand, in order to have a good idea that really can drive value and kind of like be successful as a product or as a startup, is thinking about three things. So the first thing is kind of like, um, do people want to use this? So usability. Then the second thing is viability. Do people want to pay money for this? And then the third part is technical feasibility. And what I want to understand is if no one wants to use this product is not becoming valuable. And thinking about who are going to be the users. So who are going to be the people who are engaged with this product and trying to get to speak to them. And really kind of like throughout the process, you should think about what are the hypotheses that I want to validate, kind of like what are these mission critical things I need to validate and I need to understand. And then think about kind of like write down those hypotheses and then think about who are the people who can help me answer those hypotheses. And these will be very good initial users or people I should speak to. And if you always come kind of like from this research perspective, it's quite easy to find those people. Just go on LinkedIn sometimes and ask them, well, hey, I'm doing a research project or something and I want to get your insights because you might be a user of it. Can you tell me how you would use this and this and this and this? And this is kind of like a good way how to find users, kind of like have initial interviews to understand what is kind of like what are their processes around them, how is their workflow going, what is the kind of like the fears they might having, what is their world before and after. And then you can use those people once you have interviewed them and ask them. A lot of people actually really like to speak about their job and they find it super valuable if you can ask them about the job and they like to talk about things. So this is a good way to do. And then once you interviewed them, you can say, okay, well, would you be willing to test this once I have built this? And then you have your first potential users.
Thank you for this answer. We come to the next question of Albert. Hi, Tristan. Thanks for the insights. I was wondering, what are your thoughts on AI linked with blockchain technology?
So to be honest, I'm not a big blockchain expert. I know there are actually some startups that or companies that try to link it much more, but I have not enough insights into kind of like the whole blockchain world to really give kind of like good insights into here or feel like competent I could properly answer your questions. And this is something I learned. You also have to say when you don't know something.
Thank you for your honesty. Let's go on. The next question: what C-level role in mid and large corporations should push this approach into AI?
So when it comes to C-level role in mid and large corporations to push this in AI, I think this is quite often what you see if you go into companies that do AI. They have kind of like this AI center of excellence quite often, or these specific roles of AI strategy people. And I think what is very important, and for instance, is something I also have. I developed kind of like very big canvases for people that I'm working with, where I force them to think about this process and just kind of like as if you're kind of like in this mid-level management, this could be someone AI strategist or someone really in this department. It doesn't have to be the C-level management, but obviously, if you're thinking about a company, it really helps to have the C-level support. But I think it's always kind of like more the role of these strategic people in these AI center of excellence to make sure that kind of like, okay, well, what we do at the beginning of a use case, we do kind of like this exploration process and have more or less kind of like the standardized table and say, okay, well, at least you should look at all these points and answer all these points. And it's just like doing like this because it's normally what we do with post-its, and we have this big canvas where we look at the different stages, and with the group of people that we're trying to solve this use case, try to force them to think about all these things. And just kind of like by having this process into place and having a structured way how you develop those use cases really can help just kind of like to make sure I have this human and process centric approach.
Thank you. And another question of Lam. According to you, how is the market of AI at now? Is excitement around NLP LLMs or around computer vision use cases?
So I think the market at the moment, and it comes down to kind of like really delivering value. And I think this was kind of like what I was telling the last time. And the biggest challenge what we see now is the market. If you look at a little bit the AI value chain, is that we see, and I'm talking now about the startup market, that 80 to 90% of kind of like the startups are financed by external money. And one of the big challenges is going to be to see if they can deliver sustainable value and also extract the value from the customer, so they don't have to rely on external money, but are actually able to be profitable in the foreseeable future. And right now, one of the biggest challenges to solve this is actually not the startups, but also kind of like empowering these end users, these companies, to understand the value, so they actually want to use this. Because I see a lot of very valuable things in the market that are not getting used, because it's very hard kind of like for startups to enter, especially in these SMEs. And I think this is one of the biggest challenges that we're going to have to tackle to really create sustainable value, is to empower the end users to understand how they can generate value with AI for themselves. And when we're talking about, is excitement more around NLP and LLM or computer vision use cases, at the moment, obviously, is more about the LLM. But I think also very, very exciting is now the ability kind of like to have these multimodal systems, so they can kind of like not only take language, but also can take the things that we have seen. And some of the things that I showed was, and this is also a model that almost no one talked about, but I was very excited when it came out, is for Meta, this segment everything everywhere. So this basically this model that you could use to label everything automatically. And we see kind of like now that these models are getting also much better, not only understanding or using language, but also kind of like understanding what we have in images. And I think we're going to see a lot in this field in the future. So I saw also one person wrote about the presentation. I mean, you can always write me on LinkedIn if you want to have access to the presentation. And I think the link to the video. First, can you share the link to the video so we can watch with sound later on? Yeah, sure. So I think the video is going to be uploaded anyhow, and maybe the data scientist team can make sure that kind of like the video is linked, the YouTube video is linked, so they can watch it with sound to better understand what was going on. Sorry for that with the technical problems, but yeah. So I guess this ends the time, right? That we have.
I guess, but we are not so much into time. But I guess you have many other dates to do. Tristan, thank you so much for this very insightful topic. And me as someone from the humanities, I very much value your human-centered approach towards this. It's not the machines who will take over the world.
Yeah,
With
I mean,
people like
we are still control, and we program the machines. So thank you again. Make sure to follow me. Maybe we can put in the link of my profile if you want. Always very, very happy to connect, and looking forward to see many of you, and have a great day. Bye.
Sorry. Oh.